Alright, today I'm going to be going through one of the hardest questions in HSC Math Advanced History. I want to say the hardest, but I'm sure a lot of people would disagree with me on that. And unfortunately for little me in 2024 sitting his HSC Math exam, this was the last question in this test. Out of the 3 hours you get, I probably spent an hour trying to do part B, show that if the perimeter is minimized, theta must be less than 2. I had no idea where to get the 2 from. I was so confused on that. I spent an hour on it, I still didn't get it. I think you should try the question yourself. See if you can show that if the perimeter is minimized, theta must be less than 2. If you can, I'm very proud of you. If you couldn't show it, it's okay. That's what I'm here for. I'm here to walk you through it. Don't worry, my little child. Let's break down the question. So there's 2 circles, a large one with a radius of 1 plus x, and a small one with a radius of 1. And there's also 2 straight lines with an angle of theta between them. And these 2 straight lines, along with the 2 circles, enclose an area, this shaded area right here. And that area is a centimeters squared, where a is a constant and greater than 0. And by finding expressions for the area and perimeter, show that function of the perimeter is equal to 2x plus 2a over x. Let me get my iPad stand. It's just a bunch of books. So we have to find expressions for both the area and the perimeter. Let me start with the area. To find the area of this shaded region, we should do the area of this larger sector minus the area of the smaller sector. The formula for the area of a sector is half r squared theta, where r is the radius and theta is the central angle. I think when they don't specify, you have to assume that theta is in radians. So let's find an equation for the area. And this area is equal to the area of the larger sector, which is half 1 plus x squared theta, because the radius of that larger circle is 1 plus x, and we subtract the area of the smaller sector. It has a radius of 1, so 1 squared is just 1 times theta. Now for the expression of the perimeter, which we'll call p of x because that's what they called it. Perimeter will be this side, which is x, plus this side, which is also x, plus this larger arc, plus this smaller arc. The formula for the length of an arc is equal to r times theta, where r is the radius of the circle and theta is the central angle in radians. So first let's do the 2 sides. So that's going to be x plus x, which is 2x. And then we add the larger arc, which will be 1 plus x times theta. And we add the smaller arc, which will just be 1 times theta. You can write that as theta. So we have an expression of the perimeter in terms of x and theta, but we want an expression of the perimeter in terms of x and a. So we should make theta the subject in the area equation and then sub that into the perimeter equation to eliminate it. So essentially simultaneous equations. So let's make theta the subject. First, I'm going to times 2 to both sides to get rid of the half on the right. Then I'm going to factor out theta on the right hand side. So we get left with 1 plus x squared minus 1. Now expanding the 1 plus x squared, we get 1 squared plus 2x plus x squared minus 1. And then the 1 and the minus 1 will cancel, leaving us with 2a equals theta times 2x plus x squared. Now let's divide both sides by 2x plus x squared. And now we have an expression for theta. Oh my days, that's actually PMO with this freaking Pacquiao. Okay, in the perimeter equation, I'm going to factor out theta. Now inside the brackets here, 1 plus x plus 1 is simply 2 plus x. Now let's sub the theta we got from the area equation into the perimeter equation to eliminate it. So just replace theta with 2a over 2x plus x squared. Now we're almost there. So we're trying to show that the perimeter is equal to 2x plus 2a over x. We have the 2x, we have the 2a. We just need to turn all of this into over x. So let's express the second term as one singular fraction, because that's how it's expressed in the equation we're trying to show. And in the denominator, let's factor out x from 2x plus x squared. And would you look at that, we have 2 plus x in the numerator and the denominator, which cancel out, and they leave us with 2x plus 2a over x, as we're required to show. So part A wasn't that bad, it was simultaneous equations. If you got this wrong, it's fine. This type of subbing in is really common in optimization. So if you're not that strong at this, and you want to get stronger at it, you can just keep practicing optimization questions. If you go to the last question of any HSC trial paper, it's probably going to be some hard optimization question with a part A just like this. Now for part B, show that if the perimeter is minimized, then theta must be less than 2. If we want to find when the perimeter is minimized, firstly we need to find when the perimeter is stationary. To do that, we need to differentiate the perimeter. So let me rewrite 2a over x as 2a times x to the negative 1. So this is just going to make it easier to use the power rule when we differentiate it. So let's differentiate the perimeter. The diff of 2x is just 2. This may seem difficult, but remember a is just a constant, so we treat this as any other number. So when we use the power rule, we multiply by the power, which is negative 1, and we subtract 1 from the power. So negative 1 minus 1 is negative 2. So to find a possible minimum, we need to check when the derivative is 0. That equation for the derivative we found, I'm going to express it as a fraction this time. Let's set that to 0. And now let's solve for x. So let's move the 2a over x squared and let's times both sides by x squared. Divide 2 on both sides and take the square root of both sides. And we don't have to do plus minus here because we know that x has to be greater than 0 because x is a length. You can't have a negative length. So now we know that when x is equal to root a, the derivative of the perimeter is equal to 0. That doesn't necessarily mean it's a minimum though, so we need to check using the double derivative of the perimeter. To find the double derivative, we just differentiate the first derivative again. So the derivative of any constant is 0. Differentiating this, we multiply by the power, that will give us 4a, and we subtract the power by 1, which will give us x to the negative 3. We can rewrite this as 4a over x to the 3, and we know that this has to be greater than 0 no matter what, because a is an area and x is a length, and they both have to be greater than 0. You can't have a negative area, and again, you can't have a negative length. The positive double derivative shows us that p of x is always concave up. And since the perimeter is always concave up, we can say that when x is equal to root a, where the stationary point is, p of x will be minimized. Alright, so that's great and all, but how do we show that theta must be less than 2? Well, in our working out for part A, we actually found an equation for theta. So let's write down that equation here. And now from here, we can either replace the x's with root a, or we can replace that a with x squared, because we know that when the perimeter is minimized, a is equal to x squared over here. Now both methods will end up with a similar answer, so I'm just going to replace a with x squared. We can cancel out an x from the top and bottom. So theta is equal to 2x over 2 plus x. So now if we can show that 2x over 2 plus x is less than 2, we have successfully done the question. And here's how you do that. So 2x over 2 plus x, which is just theta, is less than 2x over x. This is because the numerators on both sides are matching, but the denominator on the left is always 2 higher than the denominator on the right. Since the denominator on the left is always 2 higher than the denominator on the right, this fraction on the left will always be lower than the fraction on the right. When x is equal to 100, for an example, the left-hand side will be 200 over 102, and the right side will be 200 over 100. The denominator on the left side is slightly larger than the denominator on the right, making this fraction lower than this fraction. And this is true for all positive values of x. Now on the right there, 2x over x can simplify into just 2. And since 2x over 2 plus x is just theta, we can say that theta is less than 2 as required. Now, I don't know how you're supposed to know this, but you're just supposed to know this. It's a little bit absurd, but let me know if anyone actually found this out. If you did, well, great job. Comment down below how you did it as well, because I know there's a lot of ways to do this. This is just one of them. I can show you the way where you sub in x is equal to root a instead of a is equal to x squared. It's very similar. It's pretty much the exact same thing. I wonder how many people in the state actually got this, because I swear it's so hidden. Like, you gotta pull 2 out of the void. And yeah, I'm still salty that I didn't get this question in my HSC exam. It feels so easy in hindsight, but like, in practice, how are you supposed to figure this out? That is a crazy step. And honestly, I think that's what makes this the hardest question in HSC Math Advanced History. If you don't agree with me, let me know. Put in the year and the question number And I'll see if it's harder than this, because I don't think it gets harder than this, in my opinion. This is full optimization plus a sneaky little whatever this is. Does this technique have an actual name? If it does, let me know. Anyways, that's about it for my first math video. If you enjoyed it, why don't you watch another video? That video is probably better than this one because this is my first one. Alright, that's about it. See ya. Thanks for watching. Perimeter is concave up. Perimeter is concave up. Oh, wait, I just look so much more knowledgeable with these on. It's actually insane.